This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 2 weeks. Thanks to our audience and the partners listed on our website for supporting the podcast. Welcome to Software Engineering Radio. This episode is about EuroPLoP, specifically about some of the patterns of this year's EuroPLoP conference. This is part of the deal we've made with Hillside Europe when SE Radio became part of Hillside. The idea was to have once a year an episode about patterns and about interesting things in the patterns community. And what we did in 2009 was we recorded a couple of discussions, short discussions with authors, pattern authors, who had their papers reviewed at this year's EuroPLoP conference. And this is the episode that contains the results of that. So, I'm not going to let you know which people I've talked to. You'll see and hear that as you listen to the episode. Okay, so let's get started. The first topic we want to talk about is product line engineering. Reason is that a couple of people have submitted patterns on this topic to EuroPLoP this year. We've had a workshop where there was a critical number of product line aware people for feedback. So that was actually quite useful. And the first person I want to talk to about product lines and the patterns she wrote is Christa Schweininger. Hi, Christa.
Hi, Markus.
3 words about yourself.
I'm working for Siemens, and I was interested in aspects for a long time. And since, 2002, I got more and more interested in product line engineering.
You've left the sinking ship.
I wouldn't say it that way. It's definitely no sinking ship, but it's not having the big influence we first assumed on our business units, and product line engineering definitely has a big impact.
So we've had episodes on product line engineering before, so we don't reintroduce the topic. But let's look at the stuff you've written with your co-author and husband, Michael Kircher. So what did you write about?
So we wanted to more or less start off a bigger collection of patterns on product line engineering, since there is a lot of stuff out there and good books also, but there are not really many product line engineering patterns out there. There's an attempt from SEI, but this explains more or less the specific method on product line engineering the people developed there with their experience. And we thought that there has to be some way to make the stuff better accessible. So we started off with the very early things like setting up some roles, how to use scoping, and some general principles. So this is basically meant as a starting point for other people to jump in. So we got a lot of feedback to get more concrete, which is in this current state of the work, of course, reasonable feedback, but it was also, you have to start somewhere. Yes. And either you start with the nitty-gritty small things, or you start more in an overview way, and this is the overview now. And we will continue working on it, and we are glad or happy to accept everybody else who wants to work with us. Yeah,
this is a good point. I mean, we really want to build, and I say we because I'm involved in this, want to build a pattern language for product line engineering. And if you have experience, you, the listener, have experience with this stuff and want to contribute, you're absolutely welcome to do that. Can you give us 1 or 2 examples of some of the patterns you've had in? For example, the centralized decision-making stuff, for example?
So when you do a product line, then you, of course, have to support several products with this. And the classical way of developing products is that there is somebody who's representing the customer side or the product portfolio side for each product, the product manager. If you do a product line, you do several products together, and you want to build reusable assets for all those products. And if there are only all the product managers together, and they try to come up with a decision which assets should be built reusable, then this eventually might be quite a fight between those, because everybody wants to, get the best out of the product line for his products. I mean, they of course are interested in their own products. The overall goal of a product line, however, is to maximize some, of these abstract goals, like saving money, like increasing time to market, like having interoperable products or things like this. And therefore you need somebody who advocates this common goal and decides according to this common goal.
And this guy needs to also have certain power of overruling the specific product guys.
So a good product manager has to have the benefits of his product in mind.
Yes.
And if you have good product managers, you can't make them be, a good peer team in deciding together on all the products. So you need a special role to advocate for the overall product line. And therefore you need a specific role. I mean, it's not necessary to have, only one person fulfilling the role. For a bigger organization, this definitely will be a group of people. But you need one person to be responsible and to decide in the end. And other patterns then revolve around how do you help this one person to make the right decisions, because this one person only can decide, of course, on this, he's still a product manager and he knows, the customer side or the needs of the different products. And there is another thing you need to decide what should go into the product line, and this is the knowledge about the cost. And this is then a very technical thing. So architects typically know about the cost.
To estimate what a feature costs.
Right, what features cost, because you have first to cast those features into something like an architecture or technical decisions. So this is the first step for the architect, and then you can estimate the cost for this. And then you feed this back to the product line product manager, and he, according to his knowledge on the benefits and the knowledge he got concerning the cost, can then really decide what's, first of all, inside the product line. That's the first decision. And the second decision is what is in the core asset base.
So, I mean, if you, as you say, this is quite high level stuff, but I think it reflects your experience that all the low level technology stuff and, variability implementation stuff doesn't help much if you can't get the organization and the people to really embrace this idea of product lines.
Right. So if you know how to implement variability, you can do a great platform that probably never gets used, because it does not fulfill really the requirement of all the peers you have. And if you do not have the organizational setup, you probably even do the right platform, but probably nobody will use it because you don't have the support of the organization to make people use it. So there are a lot of different facets, and I think there is room for a lot of patterns or best practices in there.
So let's switch roles briefly, because I've also written a paper for EuroPLoP. So why don't you ask me about that?
So, Marcus, what did you write? Tell us.
So I wrote, the paper is called Handling Variability, and it is about the more technical stuff. So it's about how you cope with variability in software systems. And of course, especially in product lines, that's the whole thing. You want to express and manage variability in a consistent and useful way.
So you have different levels in there.
Yes.
That was very interesting for me when I saw it. Can you explain what levels of patterns you have? I mean, it's only 7 patterns, but nevertheless three different kinds.
So I have patterns. I start at the bottom now because I think that's better, although the paper starts at the top. So starting from the bottom, I have 3 patterns that deal with which ways of implementing variability there are in artifacts, in all kinds of artifacts. These may be source code files, these might be models or anything else. And maybe I can introduce one of these patterns later, but the next layer or the next level is a classification of the expressive power of how to define a variability or of how to specify a value for a variability. So briefly, you can either do selection, which is basically that you say a variation point can be bound to one of several alternative configurations. You basically select one of them, and the other more expressive way, but also potentially more complex, is that you create manually a certain configuration. For example, if you want to customize the process, some kind of behavioral process in a system, you might simply draw a state machine that reflects that process. Drawing this state machine isn't simply I select one of several alternatives, but you literally have to take a language, in that case a state machine modeling language, and compose the process, the state machine process. So that's 2 different things, and it's useful to keep those in mind. And the highest level is about how to distinguish or manage or separate the low-level implementation variability, and on the other hand side, have a more logical view of the variability. So I have two patterns in here. One is basically feature models, so that you take the many variation points in the code and group them together into logical variation points that you then basically represent using a feature model. So that means if you want to select something, you just select in the high level logical representation, and all the low level implementation variation points kind of are tied to this high level point and kind of automatically change in a consistent way. And the other approach here is to use basically model-driven development. So you have a model that expresses the system. In that model, you express variations, and then by feeding the variable model into a generator, of course, the artifacts that you get are also variable. And since one model or one part of a model that you feed into a generator usually results in different things in the generated code, I mean, the example is you have a model that describes the data structure, and from that you generate, the Java bean, the database structure, the XML for networking. So you change the variability only in the model, and then the generator automatically multiplies that down.
It's, of course, a pure incidence that you wrote something about product line engineering that includes modeling. This is not...
Yes, no, it's an incidence. I don't do that intentionally. But I think that this whole model-driven stuff is a very good fit for product lines.
I also agree completely. I mean, the more mature a product line is, the more you need support in making an instance of the product line, yes, of making a product. And I think that's really the way to go, even if you can't do it probably for the whole product line, right, but for subparts. And you should be aware that supporting instantiation of a product is one of the main tasks of building the base assets. Yes. So if you only have a number of components there and nobody knows exactly what to do with them, you will fail definitely. And there is also the nice handshake between our patterns when it comes to expressing variability, not in code and not in implementation artifacts, but away from code. This is exactly where product management and development come together in this variability model in between.
And I think it's a good middle ground. Like on the one hand side, you have basically configuration in feature models. It's very high level, very abstract. And if that isn't expressive enough, well, without models, what you do is you go to code and code manually your whatever specific variant want. And the model-driven stuff gives you a middle ground. It's more expressive than selecting from a feature model. It is less expressive and therefore easier to constrain and check than code. And so if you know that in some space, in some variation point, for example, you need a process that can be described using a state machine, well, then give people a state machine language and not tell them, implement the state-based behavior in Java, which has no support for state-based behavior.
Right. And I mean, there is not only product management, but eventually there is sales and people who instantiate a solution probably at the customer.
Yes.
And it's way easier for them to understand a domain-specific language than, they often cannot code because they're domain experts and they are sent to the customer.
Okay, I guess, Krista, thank you very much for participating here.
Thank you.
So another participant of the workshop on product lines basically was Dietmar Didi Schütz. Hello, Didi.
Hi, Markus.
So, Didi, why don't you give us a brief introduction, very brief, of who you are, what you do, and then we talk about your pattern.
Well, okay, I'm working at Siemens Corporate Technology in Munich in the Department for Software and Engineering, together with many colleagues, probably Frank Buschmann is known, and Krista Schwanninger from the PLE environment.
Yeah, who was on the show 5 minutes ago.
Yep, perfect.
So, and what's your pattern about?
My pattern is about reverse engineering of variability out of existing projects. So usually you say, don't start a product line engineering approach on a green field. Try to get the knowledge out of the past, and my pattern tries to describe how to do that.
So the assumption is you're a company, you have done products in a certain domain before, now you notice you're doing the same all the time or similar things, and now you want to product lineify what you're doing. And your pattern describes about how to extract the variability out of the existing products.
Right. So we have a lot of knowledge about the variability on the solution side, because the engineers are smart and they try to reduce effort as much as possible. And on the other side, product line engineering starts in the problem domain. And so we have to link these both together. And the difficulty is to find the right features to the variability we already support.
So can you give us 2 or 3 bullet points about the most important steps in doing that? How do you go about extracting existing variability?
The most important step in my point is, since it's all about effort, where do you get the best results of what kind of documents? And so since we are looking for features on the user side, it's the user-related documents like user documentation, requirement specifications, feature lists. If they exist, they are really a good source to extract that knowledge.
So it's not necessarily the existing code base.
It's not necessarily the code base. If you have to go to the code base, you can do that too. But you have much more code than other kinds of documentation usually, and so you have to spend much more effort to get the right information out of that.
Right, and also it's solution-side variability and has nothing to do necessarily with variations that the customer wants.
Right. For example, if you do it according to your change log in the code, you have to look for every change you did. What was the root cause for that? Did I do it because I needed another kind of functionality there? And justify if there's a feature behind it or if it's simply a bug fix.
So in some sense, your paper describes the ugly truth, because you don't start with a nice, very systematic domain analysis, but you rather say, okay, let's look at what we have and extract it from there.
Yeah, the domain analysis is something kind of theoretical in the beginning. It's difficult to do it completely, and there's a lot of knowledge in the past, and this is probably much better than a forecast on the future.
Right. Okay. Very good. Thanks, Didi.
Thanks, Markus.
So the next person we want to talk to is Klaus Marquardt, who wrote about, well, we won't say that as yet. So Klaus, hello.
Hello, Markus.
So please say who you are.
Yeah, I'm Klaus Marquardt. I work for Jaeger Medical, building life supporting systems. And my position is platform program manager.
Okay. So you could have talked about the product line stuff that we've talked about before, but we wanted you to talk to something else. You've written patterns about dealing with complexity this year. So I think that's a very relevant topic. It's also one that's not so very easy to grasp. So before we look at your patterns, what is complexity?
Let's look at complexity just a bit from the outside, because I think complexity is a friend or a comrade to our projects. We happen to have complex projects, and I wonder why that is. This is maybe a natural thing to happen because the more simple projects are more easily done. So they are less discussed and less attractive to engineers, because engineers love complexity and they love solving complex problems.
If they are solvable. They don't want to give up.
Yeah, right. Absolutely. And there's a large subjective part to complexity. Like some people are more capable in grasping and dealing with complexity than others. On the other hand, complexity is a project risk. So we need to deal with complexity. We needn't just kind of embrace it, but we also need to tackle it to some extent. But with this, we need to be somewhat careful, because what I learned is that if you just start fighting complexity, like introducing more control, more measures, more tracking, whatever,
or more abstraction layers,
it somehow it strikes back at a different place. So if you add more management level effort, for example, you kind of increase the complexity, and maybe you even set the wrong triggers.
It's a little bit like with energy, right? You can't create or destroy energy. You can only change the form. So if you put in more management to reduce some of the complexity, you create new communication overhead, and that's also complexity.
Right, absolutely. So complexity is also related to size of the projects. So when you have a certain size, you can't really tell where, but when you are in a complex situation, you identify that suddenly the complexity is way higher than it was before, just by adding maybe 2 more sub-projects.
Mm-hmm. So the approach you have, or you propose, or you've written about in your pattern language is to, let's say, tackle complexity indirectly by doing what?
Yeah, the usual approach, like divide and conquer or separation of concern, it doesn't really help with really complex systems. It's more like slicing a problem. Slicing a problem can make for smaller problems, right? But when you have many different influencing factors, then you cannot resolve all of them by just saying, I do separations of concern. Yeah. And this is why the approach I propose is that you deal with your contributing factors. So you have many potential factors contributing to your complexity, like including size, including amount of requirements, including how many teams are involved, including continents, including what kind of process you have to follow, and so on.
Diversity of stakeholders.
Of course, there's also technical diversity in there, and so on. So there's a lot of contributing factors, and my approach is to write them down and classify them. Mm-hmm. Whereas I'm not the first one to suggest classifying complexity. Brooks had started this already, and he's famous for his essential versus accidental complexity, and this is helpful already. I propose to add another dimension to it. So it's kind of orthogonal, that I say we have not only essential and accidental complexity, but we have also imposed and chosen complexity. And there I consider real-world projects I've seen where we say, okay, this kind of component is being outsourced or developed with a different tool or whatever, developed by a different team at another continent. And so the outline of the project, so how it's defined, kind of imposes some complexity. At least often it does.
And what do you do about it?
First thing is I need to become aware of that. So this is where I say just write down all your contributing factors. The typical thing is you are not aware of all contributing factors in the very beginning of the project. So this is an ongoing process. Yep. Just like risk management.
Yes, I was about to mention that.
Second thing is when you identify that you have complexity issues and many factors that you consider being imposed, then you need to take control of them. And this is the most important thing. So things that are imposed from the outside are basically out of your control. But in most organizations, it's ultimately more important to have a successful project than a failed project that has adhered to all artificial boundaries.
So we don't have time to step through all your patterns, but can you give us 2 or 3 examples of how you get from imposed to chosen in order to make the complexities controllable?
Yeah, sure, I can. Maybe the one that is obvious in what we've talked about is the renegotiation. So when we identify certain imposed factors as obstacles to project success, then it's the duty of the project managers to make this clear and to approach their stakeholders or sponsors and say, in this setting it can't possibly work. And when this is being accepted, then such a factor suddenly goes down from imposed to chosen, because the project may then choose whether this is a factor to consider or not. So they may choose to do something else. And this is what I mean in taking control or gaining control over your complexity contributing factors. Then there are some more or less, I'd say, obvious things like piecemeal growth, that you do not try to solve all problems at once. So this is kind of slicing down complexity, because you do not look to all problems you have to solve, but you only look for a small set of problems.
So by piecemeal growth, you mean growing your project and team size in a piecemeal way, or the system you're building?
Basically, it's the system you're building.
Okay.
Yeah. But team size.
It's the agile idea.
It's basically the agile idea.
Okay.
Yeah. Whereas I must say the Agilists haven't been the first one to mention this.
Yes. But today it's known by Agile.
Right.
One more?
What I find useful is to budget the complexity that comes from the combinatorial explosion.
You have to explain that.
Okay. If you have many things that you can configure.
Yeah, I see.
Or many options to support or whatever, then you gain complexity because you have to support each branch.
Each combination of all
each combinations
switches,
and so on. And you have not only to implement it, but also to understand it, to document it, to put in the requirements, to test it, and so on. And typically, due to indecisiveness, or due to late requirements changes, you tend to add to that configurability. And this is a bad thing. So if you have a budget, like I only support this amount of decisions that are visible to end users and administrators, then whenever you are being approached by saying, we need to do this and that, but in a configurable way, then you say, okay, which other configurations which may I take away?
Of course, the challenge of all of that is that you need the, let's say, political clout to be able to do that as a project manager. You have to stand up to the stakeholders and say, no, we won't do these other 5 different configuration switches because it's going to kill us. And they probably won't believe and say, yeah, do it anyway. So I think that's the problem in some sense.
Well, the project manager is kind of left alone in that respect, because the typical situation is that stakeholders say, we want this.
We need this.
And engineers say, yes, that's easily done.
Well, yeah, maybe. But even if they say it's tough, nobody cares because stakeholders typically don't talk to engineers but rather to the project manager.
Yeah, but the project manager is responsible for scoping the project in a way that it can be successful.
Yes.
Another one is that I consider important, and it's not mentioned in the agile world, is that project teams need to gather domain knowledge.
Right. Yes.
Because that's kind of a myth that just software engineering skills can solve all complexity problems.
Yeah, true, yes.
So,
well, what you're saying is that if you understand the domain, something that is apparently complex maybe isn't, because you now understand why and what's going on.
The personal ability to deal with complexity is certainly increased if you understand the domain you're working for. Yeah.
Okay, very good. That was brief, but I think that's it. We have to cover 5 other people for this episode. So, Klaus, thanks very much for being on the show.
Oh, you're welcome.
So the next set of patterns we're going to talk about is about open source projects, about successful open source projects, in some sense about the performance of open source projects. And we were talking to Michael Weiss. Hi. So why don't you briefly say who you are, what you do for a living?
I'm Michael Weiss. I'm from Germany, from uni precisely originally, currently living in Ottawa, Canada, at Carleton University. I'm also this year's conference chair for EuroPLoP.
I think that's one of the rare cases where the conference chair had time to actually write something for the conference he's chairing. So what is your pattern stuff about?
I'm very interested in open source projects. I've been involved in a number of them through a variety of ways, both as a developer as well as working with some open source projects. So I thought of for a while to capture some of that knowledge in patterns form. Hopefully something larger at the end.
So like a big pattern language kind of thing.
Right, yes.
And the patterns you have now, is that already the complete language, or is it more considered more like a starting point?
It's a starting point, definitely.
Okay. So why don't you give us 2 or 3 examples, or let's maybe start with the general problem. I mean, open source projects probably aren't all the same. So your idea was to classify them and find out what the best practices are.
Right, yes. The title here, Performance of Open Source Projects, so I was trying to focus on a specific aspect, because there's so many aspects. You could talk about the community, you could talk about your IP, and I don't know where to stop, right?
Yeah.
I was looking in particular here how a small to medium-sized company could develop their products faster using an open source approach. So not necessarily by using open source, that's one component, but also using open source as a strategy.
Right, okay.
And when I say performance, it's about, that open source really helps you reduce the time it takes to develop software.
Yeah.
That you also increase the quality of the software for a variety of reasons. For example, you build on other pieces of software that have already been proven. And,
so it's not about performance in the sense that a system is fast.
Absolutely. So this is the performance that when we talk about product development performance.
Okay. Now, 2 or 3 patterns that are representative of what you've worked on. I see penguins here. I like penguins.
That's a pattern I'm particularly fond of, and I think it's one that you can really say that is clearly a pattern in that and that area that has been identified, in its nature by others. So this is called credible promise, and the reason why it's about penguins, it's not just because of course the alliteration to open source, right? Linux being, but actually more deeply because one key thing that you have to address in open source is you want to get other developers to contribute to your project. So many people start out thinking about open source and say, well, let's make my code open source and the developers will come. Well, it doesn't quite happen like that. The metaphor, the penguins here helps is with penguins when they're on the flow of ice, you see them on flows of ice, and they, they're all hungry, but none of them dives in first without the others diving in at the same time.
Yep.
So this basically creates a critical mass of translated to open source right now. The path is about that you have to have a critical mass.
Why do you call it credible promise?
Okay, so so that's the concept here is that when I'm starting an open source project, it has to be enough. It has to be implemented for enough. So that others will want to contribute.
Right. Okay.
Not too far, because then it's no longer interesting for them.
Right. Okay.
But it shouldn't just be an idea.
Right. Okay.
Very rarely an idea will work. I mean, there are cases like SendMail, and a couple of others. The SVN system, for example, where there was just some very developers with a lot of reputation who threw out an idea. And people joined, but usually you have to show something that works.
Right. I just saw the title, and I would have expected it's written from the perspective of the adoption users, because you only use open source projects if you believe that they are able to deliver on the promises they make. So that's maybe another facet.
This is another facet of it. This is from the perspective, I want to create an build a project around open source. Perhaps I have some code, or starting from scratch, something from scratch, and I want others to join.
Another one?
Another one that I think building on the shoulders of others is one that I found to be very true. And one project that I was quite closely involved in, the first prototype of the system was a web conferencing system. We put it together in a very short time using open source components. We needed to convert PowerPoint to PDF, so we used OpenOffice and a variety of building blocks that you could very quickly prove the functionality that you wanted to build. And then you could maybe decide, well, maybe there's a better way of doing something, or you can strip down. But it allows you to get up to speed. The problem here basically addresses, how do you really build that critical mass that you need quickly? And one key way is, use assets or components, code that others have written.
You don't reinvent all wheels yourself.
Exactly.
Yeah, only the steering wheel that's important, maybe, or something.
It's something that differentiates open source a lot from.
Yeah. One last one, maybe?
Sure. The parallel development is kind of cute because of the picture. So it shows you two planes. In parallel. So basically, the need here is you have users who depend on or developers who depend on the software that you're writing. So at the same time, you want to evolve it. So how do you? There's a tension here, obviously. So the tension can be resolved by creating one release stream that's stable, and another release stream where you have all these where you can maintain all these experimental developments.
It's not specific to open source, though.
Absolutely not. No, this is, but it's very visible in open source, right? You have many projects, or it goes many projects that have releases. This is the zip file that you load, right? And this is the nightly build, and this is the kind of the most current build, right? So there are kind of very different, risk levels that people are comfortable with too, right?
Risk level is the right word. Okay, cool, very good. So you're obviously planning to continue to work on this stuff.
Right.
I think that could be an interesting topic for a full show. So I think once it's enough stuff, so you can talk about it for 45 minutes, I guess we can get back together and do a full show. Thanks for being here.
Thank you.
So here is our next guest on this show of short interviews. And our next guest is Vadym. Hi.
Hi.
So, welcome to the show.
Thank you.
And please give our listeners a chance to get to know you a little bit.
Okay, so I'm 47 years old. I live in the US, although I'm Norwegian.
Okay.
I started my career from computer science working for marine seismic, where I did the software development. And I did that for some years. And after that, I've been in software management.
Okay. And the stuff you've written about at this EuroPLoP and also in previous years, I understand, is distributed teams, right?
Yes.
And your patterns help cope with the challenges and problems and issues in distributed team software development.
Yes. So we over time we realized we do a lot of that in the company, but the challenges have increased as we are growing more and more global and including more and more geographical sites in what we're doing.
So what's the biggest 3 challenges in this setting, and how do some of your patterns address those challenges?
So I would say most of the challenges, if you go back and find the root cause, you'll find that you end up on communication. A very big challenge is how do you communicate on architecture and a very heavy technical material. So if you are multiple sites, it's difficult enough when you are together, but when you're spread out, and maybe the software industry doesn't have very, very clear ways of communicating architecture. And no very, very clear standards. How do we really make sure that everybody are on the same page, understand the architecture, and the development that is done locally at the site is compliant or is following the architectural principles and not breaking it?
So, and what do you suggest to do about that?
So I think most of the patterns are actually kind of in 3 levels.
Right.
There are some that are for the team, and they would be more applicable within this area. There's also things about how you set up the whole project and how the organization around can support the project. So again, it's around communication and the ability actually to come together. So that's a fundamental recommendation I would make. I know in the industry today it's very often difficult for teams to be allowed to travel and come together. But if you really are doing complex development over some time, not just a few weeks, but maybe a year's type of development, the investment in actually bringing people together is very important. So basically what we suggest is that first of all you come together early and meet and build up the knowledge of each other in the team and build up the trust and start developing the architecture together. And then you come together on certain intervals, maybe every 6 weeks. I think that's what we would recommend, not more than 6 weeks. And you can, travel to multiple sites, so it doesn't need to be the same people traveling all the time. So if you have 2 or 3 locations, you alternate so that everybody spends some time traveling. During the times that you meet together, there's another thing that's kind of the foundation here is some agile thinking. If you work with iterations, try to finish an iteration together and start the next.
Right.
And then you try to align on the architecture, on the user experience, and sort of, you kind of align everybody on where you are, what the user feedback is, plan for the next iteration. Then you may have a couple of iterations that are done remotely, but again, the next time you meet, you synchronize it with an iteration transition phase.
So this whole travel business can become quite expensive. So I guess the primary reason for having distributed teams is probably not the idea that you want to save money, but more that you can't motivate or make the good people you have everywhere to move together. So this is not about outsourcing, right?
No, it's definitely not about outsourcing, although I think people who do outsourcing may find interesting material in there.
But they will argue that if they do outsourcing and then have let all this travel cost, then the benefit goes away. So that's why they don't travel, which of course is why outsourcing then sometimes fails.
So if we park that for a couple of minutes, we can talk about where we came from doing this. So like many big organizations, they grow by acquisitions. Or there may be a desire to be present in a certain market, which means that you want to start up an activity in another country or in another geographical area. And over time, you will realize you have experts in multiple locations that when you go for something new, they need to be involved. And it's not really feasible to move them all to one site.
Yeah.
So that's kind of the background, I think, for a lot of what's happening. When you're outsourcing, I think there are other patterns, not necessarily just from this, but also from other organizational patterns that you need to think about, how you structure the work versus where people are. And even if you're outsourcing, if the whole team is in it's one location actually, and you've outsourced the whole project, they are actually together.
Yes. Yeah. So 2 or 3 more representative patterns. I guess the idea that you should travel and meet is, well, in some sense it's obvious. It's just that many people probably don't want to see the reality.
Yeah, but it's that combined with what you are actually doing when you are together. So maybe we should talk a little bit about what happens when you're not together.
Yes, exactly.
So we have some patterns about, flexible work hours, for instance. So that's very important when you are in very different time zones. So that's what we started doing. Initially, it was a lot between Europe and the US, and it wasn't such a big challenge as if when you included Asia, and you have teams in the US and teams in Asia that don't really have any overlapping work time, it becomes very challenging. So trying to emulate some of the meetings and communication that you have in agile teams by a combination of more formalized working meeting time, so that you know when people are available. So you can, if I have an issue, I know that this evening there will be a get together and I can bring it up. With a development environment and communication tools for the team, so that they can also hook up whenever they need to.
Chat, video, webcams.
Yeah.
Okay. Do you also look at the tooling? I mean, like, distributed version management or something like that?
Yes, I would like to talk about that too. So that's another thing that is very important. And I know when I'm presenting this at conferences and talking to people from other companies, they ask a lot of questions around that and say, this is a very difficult theme. So that's where some of the practices on a company level, or at least for the engineering organization, come in, that you have to do an investment in trying to standardize workflows and tools so that we actually use the same everywhere. We do actually have an internal source control and builds a configuration management system that is totally transparent on locations, which is I'm not sure we recognize the importance of it. But without that tool, I think we would have been in trouble. If you have different source control, different code bases, it makes it very, very difficult.
I think it's also important because although you said that you cannot obviously move everybody to the same place, I think you will have many people moving around over the years. Like, I mean, if you have the chance to go to basically any country on the world, some people will want to do that. And if you have the same infrastructure everywhere, it's much easier for them to get up to speed again.
Yes. I'm actually often asking other companies how they're doing this when they are large organizations. And I realized that we may be a little bit special in this, that we are operating as one company worldwide. And so we have, when you're moving around from location to location, you will see that you meet the same tools and the same, maybe even the same, to some extent, the same culture, the same thinking. And I think that happens also because we do move a lot of people. So typically in each of our development locations, maybe up to 40% of the people there will be what we call expats. They are not local. And they move regularly around in the system and bring knowledge from one location to another location.
Is that a side effect, or do you think that's even a necessity to make this distributed environment work?
I think in our organization it's deliberate. I think it's maybe not 40% is necessary, but
Right.
some movement of people also to build up that trust and respect thing, because to avoid this them and they and us
Right.
type of thinking.
Okay, anything else I forgot? Well, your pattern stuff is probably much bigger. One more you think is kind of a highlight?
Yes, so let's talk a little bit about what's happening also on the big picture in the organization.
Mhm.
So there are things that need to be in place for this to work also on the organizational side. Initially, when we started, we tended to not have the project understanding clear.
Mhm.
So you might have people in one location reporting to a local manager, but actually working for a project that was based in another location.
Yeah.
So that was difficult. So you need to set it up as a clear organization around the project with clear decision making, so it's not confusing who is doing what.
Mhm.
And also maybe things like financial system and human resource systems to be able to work with that one project team, which is actually on multiple locations.
Mhm. Okay, very nice. Thank you for
Okay.
being on the show.
Thank you.
So here is our next guest. It's Paris Avgariou. I hope that's spelled correctly.
It's pretty much.
Okay. Hi. So please introduce yourself so people know who you are.
So I'm from academia. I'm a professor of software engineering in the University of Groningen in the Netherlands. And I've been doing research in the field of patterns for the past maybe 6 or 7 years. And I've started together with a couple of colleagues here in EuroPLoP, Uwe Sdoen and Neil Harrison, an attempt to try and reflect upon the actual usage of patterns. So not just about writing new patterns, but about using the existing ones.
Mm-hmm. Well, kind of case studies and scenarios where they fulfill their promises.
Exactly.
Mm-hmm.
So we are looking at both practitioners and academics. What kind of approaches exist in the industry right now? Approaches that are not particularly scientifically sound, but they still work. Approaches that can, use patterns to solve different problems in
Right.
companies or organizations.
Yeah.
And on the other hand, we have academics that are performing research about the use of patterns, try to make it more systematic, if you like.
Mm-hmm. So this year you have submitted a paper about using patterns to avoid the architectural knowledge in a system just disappearing into nowhere once a system is built.
Right.
A problem we all know.
Right.
So why don't you elaborate on the problem for a minute or two, and then we look at a couple of patterns, or well, how you used patterns to avoid this problem.
So software engineering is in essence a knowledge-intensive activity.
Mm-hmm.
Throughout the whole life cycle, the different roles in software engineering produce knowledge and consume knowledge. And by knowledge, we mean pretty much every information that is relevant. For example, the stakeholders may have concerns about the system to be built, if you like, requirements. This is important knowledge.
Mm-hmm.
The architects make decisions about the system. This is also knowledge. Those decisions have rationale. Why were they made?
Yeah.
This is also important knowledge. The problem is that usually this knowledge resides in people's heads. It's tacit knowledge.
Mm-hmm.
And eventually people move around organizations and the knowledge dissipates. It gets lost.
Mm-hmm.
So we are trying to solve this problem, because when knowledge gets lost, people spend an awful lot of effort and, of course, money to try to recover the knowledge.
Yeah. Mm-hmm.
So the other side of this problem is that documenting knowledge is very expensive.
Yes.
If you have people like architects who are very expensive themselves, you cannot really ask them, can you stop what you're doing and write down all the design decisions you made? That's not going to happen in practice.
Yeah. So suggestions to solve that problem.
So we are trying to solve this problem by using patterns.
Well, that was not a surprise. So far, so good.
Right. The thing about patterns is that they can provide you with a cheap way to document the knowledge. And how do they do that? Patterns carry a lot of important baggage with them. So they have a very well documented problem They have a very elaborate solution as well as consequences, related patterns, and all that information. Now, this is reusable knowledge. So patterns are applied in a system, and architects and designers apply those patterns. Even if architects and designers do not explicitly document their decisions, they have applied those patterns. So just by looking at those patterns, you can somehow mine the decisions that were made.
So you're trying to extract which patterns have been used in a system from existing resources, code, documentation, whatever.
Exactly.
And because a pattern has a well-defined set of circumstances when it should be used and why it's used, what it does, that allows you to kind of infer that those problems the pattern solves are there in the system.
Exactly. So we have created a kind of a meta model. What does it mean to have an architectural or design decision? What are the different requirements associated with that? What are the different artifacts like models or code that are derived from that? And we sort of use the information from the patterns to fill in all the knowledge that has been lost. So we are inferring, for example, what we call context knowledge. So the problem part of the pattern, which is somehow related to the requirements. You applied pipes and filters just because you wanted to have a system that implements a specific process, which is sequential. Then we have the reasoning knowledge, which is basically why you made, what the kind of decision you made and why. And then we have the design knowledge, which is the actual end result, the solution that came with the pattern in terms of components and connectors, and of course, essentially code.
Now, since you're in academia, you cannot just, walk around through the world and say, this is great, I can do this. I can just say, my experience tells me this is cool stuff. So some people believe it, others don't. But you can't do this. You have to prove this stuff. So do you have any evidence? Did you do any experiments that kind of prove that this approach of, recovering architecture through patterns works?
Not so far.
Okay.
What we have as experience so far didn't have to do with patterns. It had to do with how organizations, what kind of knowledge they use in their business, and how that knowledge helps them to perform their day-to-day activities. We found out a bunch of problems there, but we also found out a number of solutions. For example, we saw that in different organizations, documenting knowledge is very expensive. So another solution is to have personalization, which means that you don't necessarily write everything down, but you know what person knows what.
Okay. Yes.
So this is also, a more pragmatic way to spread knowledge within the organization. As far as this particular work about patterns, we are just starting with this, and our aim is to basically implement this thing into a repository that acts as a tool to recover knowledge in specific case studies. And we are, of course, looking for industrial partners. We have a couple of companies in mind, but no specific results yet.
Okay. And you've also run a workshop here where you've tried to trick people into using this stuff so you can verify that it actually works.
That's exactly right. We made a sort of an empirical study where we had a control group and a test group, and the control group had to document knowledge of an existing system without explicitly using patterns, and the test group did the opposite. They were asked to explicitly use patterns. So we sort of gathered the data out of this experiment, and we still are analyzing the data, but as a preliminary result, we found out that the quality of the knowledge that has been recovered with the use of patterns is higher than without.
In some sense, that's one of the original promises that patterns, set out to deliver, which is if everybody knows patterns and if you mention them in conversations and also in documentation and other things, this acts as a little bit of like a macro, right? You mention a word, you can expand it to all this knowledge that's behind the pattern.
Exactly.
So you're kind of trying to prove that.
And we are trying to fill in the details. So just by saying that, this is a client server using a broker, you've mentioned 2 patterns, but you haven't said anything about the details. What was the problem you were trying to solve? What other alternative patterns we have considered? Why you chose a specific one? And what are the consequences to the system quality attributes, for example? So all this information is implicit when you say the name of the pattern, and we're trying to have a more systematic approach of documenting that.
Cool, very nice. So I guess once you've finished this work, you might maybe come back to the show and tell the listeners what the results are.
We'll be happy to do that. And in our community, we usually make a lot of claims. I mean, the academic community, we make a lot of claims, but not always provide evidence. And our approach is evidence-based. So we are really performing empirical research and trying to have concrete evidence that this stuff actually works.
That would be a new buzzword: evidence-based software engineering. There is evidence-based medicine. So something like that.
Well, that's what empirical software engineering in essence does.
Yes, okay. Okay, thanks for being on the show.
Thank you so much.
Okay, so here is yet another guest for this episode on EuroPLoP pattern material and pattern people. Welcome.
Thanks.
And I didn't mention your name because I wasn't quite sure how to pronounce it correctly. So why don't you introduce yourself and pronounce your name correctly?
Okay, I'm Veli-Pekka Leranta from Tampere University of Technology, which is of course located at Finland.
Okay, which we've had an episode with Juha-Pekka Tolvanen from Metacase, so people probably know the accent. So you've written a paper on architecture patterns for distributed embedded control systems. And before we look at some of the patterns, I think it's a good idea to let our listeners know what distributed embedded control systems are and what the problem is, why there is specific architectural patterns for them.
Maybe I should tell a little about our project. We are doing architectural evaluation for the embedded control systems industry in Finland, and we have visited some companies there and collected a pattern language there. The systems are like elevators or forest harvester or mining trucks and so on. You get the idea which kind of machine we are talking about. And the main characteristics of software in that industry are they have to be reliable, of course, fault tolerant, they have real-time requirements, and maintainability is one big question because
they have a long lifetime.
Yeah.
Let's look at 2 or 3 of the patterns. We probably can't cover the whole paper, but that's unnecessary. So let's look at 2 or 3 of the patterns that are maybe non-obvious to some of our listeners, maybe.
Well, maybe I should start with the one that is quite fundamental. It's called separate real-time. And usually with these machines you have real-time requirements, but of course you want some higher level functionality there. You want to provide logging, error handling capabilities, maybe debugging and user interface for the operator. So you need high-end PC there. But the problem is that usually these high-end services are more they are not fault tolerant so much. And there is no way that we can take the risk that the real-time part of the system can be interfered with these programs. So you have to separate these two to ensure that nothing dangerous is going to happen. For example, in the forest harvester, you have to make sure that the log is not fed through the cabin.
Oh, that's actually checked.
Yeah.
Oh, quite. I didn't expect. Okay.
You can do that if you are trying.
So the thing knows the length of the log, so you know when it will collide?
It knows the speed and the distance to the cabin, so it can calculate and the direction of the feeding where the harvester head is feeding the log. So what you're saying is basically, as you say, you should separate those two. But if the real-time part has to feed information to, let's say, a user interface, and that is slow, how do you avoid that the slow user interface, slows down the real-time part? There needs to be some indirection or something in there. Well, you have a bus there, and you have a message queue that is used at between there. Actually, that's a pattern in our language.
Okay.
And so it's solved. And in addition to these 2 levels, there can be more, of course. There can be 3rd level, that is emergency stop.
Right.
There you have very, very, very strict response time requirements, because you have to make sure it really stops when it's supposed to.
So we had once an episode where we talked to Klaus Marquardt, who is working in these life support systems. And what I think is funny is that in their case, the emergency, well, it's not an emergency stop, it's an emergency open the oxygen line so the guy doesn't die. And that's actually mechanical. There is no software in it at all.
Well, basically the emergency stop level is something that is really in the hardware, but there might be some software in there.
Okay.
And of course, maybe the software part is just like it is over. Everything else is overridden in the software. It's the priority one to stop everything.
Another one.
Well, here's a permit authority pattern. As we are talking about distributed systems here, we have multiple nodes that are located in different places in the machine. The decision making is a challenge. How you do make decisions and ensure that the consequences will be safe. They will not harm the machine or the operator.
Yeah.
The solution basically is to add one dedicated component that has the system state. It keeps the state in one place and make sure that the information is new enough there. And every other node in the system, they will have to ask permission to perform an action from this supervisor node.
Problem, of course, can be that there will be, or there might be, a bottleneck or communication bottleneck there if everybody asks the guy, the central decision maker, for everything.
Of course, for example, the emergency stop, as we discussed already, you can't ask that, you do it. You go to the safe mode. You don't ask anything. But usually when you start something, for example, a driver could ask from the authority node that, can I start engine? And maybe there's something, for example, handbrake is on, so maybe transmission controller would ask if there is a handbrake or something like that. And maybe third one, it's called sandbox. And the idea is that usually in these systems you have also third-party applications, such as remote diagnostics or maybe in case of mining trucks, they have their own software at the mine that is sending drilling plans to the machine or information. You should go there and pick up some stuff. And it's a problem because we need to offer interface for the third party to how they can use the system. But they have to do it in a way that is safe. It cannot interfere with the normal operation of the system, of course. So we basically say that you should add a sandbox or kind of a virtual machine there where you put those software and you can give the interfaces to the third-party developers and it increases the time to market of this software for the third party. It benefits them. And of course, when it's sandboxed, it doesn't cause any harm to the actual operating software of the machine.
So since you're talking about harvesters and mining trucks, do you actually get to play with all these machines when you do this research, or is this...
Unfortunately, no.
Okay.
But we have tried the simulator.
Okay.
It's nice.
Cool. Okay, so I guess, I guess that's it.
Well, pretty much. I want to say that one thing more, that we are continuing this work. Now we have 35 patents.
Wow.
And we are developing a language. And our goal is to get a generative language for this domain.
Cool.
So new developers can take it and, okay, this is the way I'm going to build this machine.
But you've submitted only like six or seven patterns, right?
Yeah, we have a part of those now written down here, and we want to get feedback on them before we go forward and write all of them. We have all these like
pattern ideas.
Yes, and there are some notes on there. So this is work in progress.
So once you finish this stuff, why don't you get back to me and we'll do an episode on this in detail? Because we've had a couple of things on embedded systems, but not enough. And the nice thing about pattern language is, for me as an interviewer, it's very easy to step through and ask the right questions because I just take the pattern title and formulate it as a question. So if you're interested, just get back to me when you're finished.
Sure.
Cool. Thanks for being here.
Thanks.
Thanks for listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig Reddit Delicious links and the /dot button. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsive Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.